Okay, then the last lesson in this chapter is on problem solving. Okay? And so I want to review with you what we do with problem solving in order to make sure that you're not making simple mistakes and you can help to figure out what the problem is all about and how to solve it. So first, whenever you're doing problem solving, read the problem more than once. Okay, read and reread the problem. It's really, really hard to do a math problem based on a word problem situation by just reading it through one time. Because oftentimes they're complicated and the words are complicated. And there's a lot of details in it. So always read it more than once. Okay? Read and reread. Whoops. Try that again. Reread the problem. Okay? And write an answer statement. Okay? The answer statement helps you figure out the label for your answer, to make sure that you have converted it correctly. If it's asking for something in minutes and you found hours, then you have to convert hours to minutes. So and things like that. If you get a problem, get an answer, and it's asking for an amount of money, then you got to make sure you put the dollar sign. Things like that. Area is always labeled with what kind of unit? Unit squared. Perimeter is always labeled with regular units. And so you got to make sure that you label correctly. Then, draw a diagram. Okay? Draw a diagram. Sometimes the diagram, it works, we talked about the comparison models, where you draw a box and then you draw another one that's a different length. And then you try to figure out how to compare those two, whether you add them together or you cut a portion off of it. We're going to do some problems that are combination problems today. And so we'll use a different model for that. But then once you've figured out what all of the numbers mean in the problem, then do the math. Okay? One of the things we're going to look for today is a pattern. We're going to look for patterns in order to do the math. Okay? So, what I want you to do is turn to page 168. We're going to do one of these problems together. Combination problems. This first one, number 1. In a tennis tournament, each athlete plays one match against each other athlete. There are 12 athletes scheduled to play in the tournament. How many matches will be played? Okay? So, read it again. Reread it. Each athlete has to play every other athlete. How many times? Just once, right? One match against every other athlete. There are 12 athletes scheduled to play in the tournament. How many matches? So we're combining, we're basically making groups of 2, right? Each athlete with each other athlete, groups of 2. So, write an answer statement. What is the question being asked? Somebody give us an answer statement that you could write.
There will be blank amount of matches.
Okay, blank or blank total matches. There will be a certain number of total matches. Okay?
Not even correcting anything.
Then, basically, what has to happen for combination problems? Especially with pairs of 2, one thing we can do is make a list on one side. So there's athlete 1, 2, 3, 4. And then going down, make a list of all the choices. 1, 2, 3, 4. And then start to make a combination. Okay? So, can athlete 1 play against him or herself?
No.
No. So that's not a match, right?
No.
But 1 has to play 2, 1, 3, 1, 4, right? How about 1 versus 2? We already have 1 versus 2?
Yes.
Do we have 2 versus 2? No. But 2 has to play 3, and 2 has to play 4.
So this is a subset stage.
Yep. And how about 1 versus 3? They already played. 2 versus 3? Already played. 3 versus 3?
Already played.
No. Can't play against yourself. But 3 has to play 4. And how about 4?
They can play 1.
1 versus 4 is already played.
Oh, I didn't see that.
2 versus 4, 3 versus 4, and 4 versus
4.
You're right. So, if there were just 4 athletes, how many matches? Well, what we could do is we could start with 4 plus 2 plus 1. Right? Would this pattern continue? Or if we did 1 plus 2 plus, the 3. Look, 1 plus 2 plus 3.
That equals 6.
Would give us how many matches? 6. By adding up the rows separately, you can get the total matches, right?
Yeah.
Yep. Why aren't there 4 matches here for 4 people? Because 1 can't play themselves. Okay? Now, what we're doing is we're looking for a pattern. Right?
Yeah.
So for 4 athletes, we go 1 plus 2 plus 3. What if there were 5 athletes? There would be 1 plus 2 plus 3 plus 4 matches. Right? For 5 athletes. Now, your problem is 12 athletes. Okay? Don't be disruptive. Okay? Then be quiet, please. Do you guys understand what to do?
Yes. No.
Make this chart for 12 athletes. And then try to solve it by using the pattern. Okay? I made it for 4 athletes. Make it for 12 athletes. Okay? Then do number 2 and number 3 as well. Okay? So on page 168, I want you to do 1, 2, and 3, and then also do a 13 through 18 from the previous lesson.